Hello, hello, and welcome again. Today, I will try to build another mission that I already have in my Unity version. I will try to build it here because it needs a different kind of target to end the level, and which is going around the planet and getting the spaceship to a higher orbit. And then we see where we go from there. At this point, today I was trying to solve that camera problem of having more than one target. The solution is not quite what I was expecting. I believe this is not very efficient, but basically every frame I calculate the boundary box and I just get the minimum maximum of X and Y positions, and then I get the center of this box. Is a box. Here is the center. I don't actually like it because I believe this is extremely expensive, but I don't know. I don't know. My internet is very bad. Anyway, I'm sorry for that. Now I think it's a little bit stable, a little bit more stable. Anyway, if I break up a little bit, and if you don't understand what I'm saying because of that, just ask me to repeat. So the thing is working. So if I play, let me just mute the music. If I play, the camera follows more than 2 targets now, but this is not yet very smooth. And okay, this kind of solves the problem. So here I am going around with 2 targets. If I let go, oh, I will break. Okay, so now it's only 2 targets again. Let's restart. I always forget to go in the right direction when testing this. A little bit slower. Let's kind of rotate upwards. Let go. Of course, the camera does not zoom out yet, so, but this is centered on the 3 targets. And now it passes to the 2 targets, so it's kind of working. I didn't do the zoom yet because I don't like this solution, and yeah. Anyway, today I'm not going to solve this problem because I need to think about it a little bit more. What I'm going to do is to create the new level, which is getting to the higher orbit. So the ship is already around the planet and I need to go to a higher orbit. That means that I need a specific kind of target. Let's create the level, and while I'm talking I will explain. Orbital turn, this is a so the level structure, each level has this structure. I have a node to the user based. This level manager is the thing that handles the buttons there. The level progression gets stuff like the fuel, and if I'm actually progressing, but I believe I will need to change things on this script for this new kind of level. World environment. This is related with the visuals. So you see this, the spaceship is a little bit, it's glowing, and yeah, and to do this kind of visuals, I need to have this global environment with the settings for the glow. And I can have here more settings. At this point it was just to test if it was working. And I have 2 layers because I don't want the interface to glow. So the glow only affects the canvas layer, and the canvas layer 2 is where I have the interface and the helper. The helper is this text over here that I'm not sure if I'm going to use. Maybe if I have voices to explain what to do, maybe I don't need that. We will see. And then I have stuff around the level, map for the triggers for the sound, for example, and the camera. In this case, the camera is, I don't know why I don't see the camera. I should be seeing the camera. Maybe it's, I don't know, some weird interface feature that does not allow me to see the camera. Yeah, not on the bottom, not. I don't see the camera, but it's there, it's working. Oh, now appears. Okay, now the camera is here. Sometimes, oh, because it's inside the level, in the layer, and I want it to go outside of the layer. So if the camera is outside of the layer, I cannot see it in the interface. I don't know why. Anyway, so I need to replicate this structure. Let's close the stuff I don't need. I don't need the moon. I don't need the lander. I don't need the trail. I don't need the broken ship. This one also. Engines, sound player, I already fixed this problem. This is the level I will copy from. Maybe I just duplicate this and I work from here. So this empty close. Let's go. Rogue Planet. Control Shift S. Save as. Let's call higher orbit. Okay, higher orbit. Let's change this to higher. I don't know, higher orbit. I'm not sure about this name. Anyway, level manager is the same. Progression, I don't know yet. Level objectives, also I don't know yet. This stays the same. Now the planet, I don't need this planet. Well, I will need a planet, but will not be this one. It will be Earth. Space background, yeah, it could be this one. The camera is too far away, so the planet will be around at the center, maybe, I don't know. The spaceship will be I need to take this UI out of the way. It doesn't matter where it is, it just needs to exist. Then when the level starts, this goes to the right position with the right zoom, the right scale to fit the screen. So I will start already around this planet in a stable orbit, and I need to go to a higher orbit. So this planet needs to be fixed because I don't want the planet to move. So freeze. and 0, 0. I believe this will be okay, and the spaceship needs to start moving. Let's see if this number is enough. Maybe it's too fast, or it's too low. I fall immediately, so maybe 10,000. $10,000 is too much. I need to program something that actually calculates the correct speed. So I point to the planet. It's not kind of round, it's an oval. And I have to fix another thing in the polar gravity, because it's getting higher just because it's floating. See, now it's higher, and this shouldn't happen. But my problem now is that it's not centered. So a little bit more, 8,000. Yeah, looks like now it's higher on this side and this side. So maybe I can adjust the position now. Maybe around here. This is setting up. This is a little bit annoying. No. Let's go 7,000 again and adjust the position. It's more or less. No, it needs to start falling. Let's say like this. I really need to program something that show me the preview of the route. If I go like this, it will stay even wider, I believe. Whoop, let's go there. And I need also to give it some rotation. That's something that I don't have yet. Is a starting rotation. Okay, it's kind of working. It starts to fall very fast. Okay, this will be enough for the testing. Let's first add here a new thing. I have the where is the starting start local force. I want to have a start local rotation, something like that. Export wait, start local force. This is not public. Strange. So I have a name for this. This is called what? This is called something something. Ship UI screen. This is called spin rate. So let's go start spin rate. Start local force is sent to somewhere, to the polar gravity to the polar gravity file, sorry. This is being sent to the polar gravity start local force because the polar gravity needs to have a direction before calculate the attraction, but the rotation does not interfere with that. I believe the rotation is only inside is directly inside the rigid body manager. Where is linear velocity, angular velocity? This is being set up here. So that start angular start where it is again, this start spin rate needs to go to the rigid body manager, and maybe I have here public void set start spin rate. This is expecting a float called, of course, spin rate, and from the other one copy so from ship one start spin rate. This can happen here. Rigid body manager dot set spin rate, set start spin rate and spin rate. Start spin rate, or is start spin rate? No, it's not spin rate, it's start spin rate. Okay, so this number is sent in the beginning, so at before the first frame. And now in the rigid body manager we need to say spin rate something something. Where is the spin rate? Rotation decrease, angular velocity. I don't know, because angular velocity is not the same. Oh, is the same as spin rate? I believe it is. Let me see. I'm sending the numbers from the ship script, so game events. What? No, okay. Sorry. This event system. We send the rigid body manager rotation degrees. This is actually the rotation. And then we calculate that to have the angular velocity is the spin rate. Yeah, with the current movement transmits local velocity. Let me check the panel height. The panel height receives that event. No, it's not this one. The UI screen, sorry. It receives the event, get current fuel, get current movement. Spin rate, okay, spin rate. Yeah, that number is the spin rate. So this number over here is the spin rate. Basically, we are doing this math function to the angular velocity. Now we need to do the opposite, I believe, because we need to set up the angular velocity from the spin rate. Radians to degrees, maybe we need to do degrees to radians, and that's it. Let's try. Where is the start? Start is here. So rigid body manager, start spin rate. This will be start speed. It's not speed, it's spin. Come on. Copy. Sometimes I press the wrong keys and I don't understand why. Where is the start speed rate? It's here. Delete. Okay. So let's paste here. Oh, come on. Rad to degree. Rad to degree. What we need is the opposite of this. Copy. So we need degrees to rad. I don't know if that exists. Yes, exists. Okay, and this, instead of being the rigid body manager angular velocity, this will be the start spin rate. Copy, paste, and this everything is going to be the number we will send to the start. Let's see if this works and if the number actually is the one I'm looking for. Okay, so hit play. I'm in the wrong scene. Close, close. Higher orbit. Maybe the camera could be a little bit closer. Where is the camera? Camera. It's here. This will be enough for this level. So I'm sending 0 at this point. So I shouldn't have... What? Why? Why so much? What did I change accidentally? Suddenly this is too much. Why? Did I change something? You can do it, bro, even with 3 views. You can do it. Thank you, man. Thank you, Adam. Adam, I believe. Yeah. The views, of course, I would like to have more views, but you are my rubber duck, you know? I need to talk to someone to explain myself what I'm doing. Let's do the thing. 3,000. I will fall. Oh, yes. Of course I will fall. Maybe 4,000. I don't know. Maybe I was not pressing the enter. This is annoying. If I write a number and I don't press enter before play, it will not accept the number. So maybe I was changing and having always the same number. Yeah, let's go 5,000, enter, play. Nice. The concept of the game, what is the concept of the game? The concept of the game is a chill space flight simulator. You know, you just have to kind of enjoying zero gravity stuff. That's it. At this point I'm doing a level where I have to orbit the planet and then I need to go to a higher orbit. But I can play a little bit what I have. So if you didn't watch the other streams, I will play other levels just for you to understand the type of game. So the first 3 levels just to learn how to maneuver the thing. I will not play that one. And this is the first actual something is happening.
Prepare for main engine burn to decelerate as you approach the station. Ready to start rotation? Engaging now, ready to maneuver into docking position. Use thrusters to align with dock 2.
Yeah, dock 2 is not dock 2, is dock 1, but yeah.
Roger that.
Technically I can dock on dock 2 and the level will end anyway, but this is the one I want.
Roger that.
So this is the kind of, it's like NASA stuff but chill mode, you know, just relaxed. No aliens, no explosions. Well, I can actually explode. If I go too fast, I can break the spaceship. Like this is the one of the levels where I need to insert into a rogue planet orbit. But of course, if I accidentally do this, I will break apart. So, for example, this one, I have to go out of this dock, pick up this new model, connect to the space station. So let's grow the space station. I think I can have more than one level of this kind. So we actually have to build the space station as long as the game goes. So you start just with one module, and at the end of all levels you have the entire space station built, for example. And like every 5 levels or something, we have a new model to add to the space station. You know, just chilling with low gravity or zero gravity and dealing with acceleration and braking and rotation. I did a proof of concept of this game like some years ago in Unity. And I have that in itch.io. I believe if you go on the, I have the link in the in the video description, and you can actually play because it's a web browser stuff, but it's very different. It was it's the same drawings, but it doesn't work as it's working here. And then I decided to rebuild the game in Godot and actually do more levels and more stuff. You know, the menus and the save data and sound and whatever.
Auto lock activated. Roger that.
This looks easy because I played this level 100 times already this week, so this is not very easy for the first. I'm a teacher and I put my students to play this game and they cannot finish the level even after watching me doing it. So maybe I need to adjust the why do you switch to Godot? Well, because Unity want me to switch to Godot. That's why. They didn't like my presence in the Unity platform. That's how I see the thing, you know. If you don't know what I'm talking about, basically Unity told people that, yeah, if you use Unity, every time someone installs your game, you need to pay 20 cents or something like that. And everyone was like, no. Because if someone reinstalls your game 100 million times, every time you need to pay 20 cents. And that can be very problematic. So I switched from Unity just because I'm happy to pay a license, but I don't need to pay every time someone opens the DVD drive and puts the CD inside, you know? Come on. Anyway, continue our problem here. I have an orbit. And I don't have rotation. So let's see if the rotation is actually being set up properly. This is too fast. So I have here a spin rate. Let's say, let me play first and to see the number I want. Play. So I want the thing to start with this number over here. It should be pointing to the planet or something like this. So the spin rate should be around -40. Let's see if this works. -40, play. It doesn't work. Maybe I cannot send that to the rigid body manager at that point. Maybe it needs to, no. It doesn't need to go to the polar gravity, because the polar gravity does not deal with rotation. Global position, rotation, no results. Okay, so this is not where I want to send the thing. I want to send it to the rigid body manager. Okay, angular velocity equals to is C# hard or easy? Well, it's the same as any other language. You need to get used to the syntax, and as soon as you know that, no matter the language you are using, and as soon as you know the syntax, and as soon as you know the structure, because if you look here, you have a specific structure, you declare the libraries here, you have the class here, so your script is this thing, you declare the variables here, every variable declared inside something will be only available inside something, and then you have like enter tree is when the object is put in there, the red is the first thing it happens, the process happens every frame, the physics process happens every physics process frame, so it's kind of slower. when you know those things, and you kind of used to the structure, this is the return, this is the name, this is what it needs to work, or the variables that will need to work. This is a function or a method called in C# is a method. So when you know that, you don't think about it anymore. Is public something is like a function? Yeah, this is a function. Set mass is a function. I create this function. This is a function that I create for this script, and I need to set up the mass of the spaceship in the beginning from other script. So I make it a public so the other can access it. So in the other script I say set mass and I send it a number, and inside the script this will happen with that number. So I can create my own functions, or in this case in C# is called methods, not functions, but it's the same thing. It's just a name. In this case the void means that it doesn't respond back. When I say in the other one set mass 30, it will not respond to the other script. But if I have here some kind of, I don't know, imagine that I need to calculate here something and then I need to report the result of the calculation, I can have a float or an int or whatever I need to return there, and then I need to return whatever. And of course this is an error now because void doesn't allow to have returns. And that's it. So this is a structure and it has a lot of things that we need to know. You always start the sentence with whatever you need to start, but you always close with a semicolon. So technically this is an error because you can have is first frame equals true from frame count equals 1. This is like one. This is one line of code unless you close it. So you know it doesn't matter if it's here or here or here or here, you know, I can have the entire script in just one line if I want. It's kind of difficult to read, but as soon as you understand the structure and the syntax, coding is just logic. It's just the algorithm. And if you know how to code in JavaScript or in C or in whatever other language or in Godot script, and you know the syntax of this one, you easily adapt to it. So I'm used to C# because Unity was C# mainly, and that's why I prefer to use C#. I'm just used to it, and I don't like the thing of Godot where if this is inside the ready because it's inside this curly brackets. It's kind of visual, you know, it's very easy to understand what's inside of what and whatever. But if I do this in Godot script, I will have an error because now the indentation is what marks what is inside and what is outside, and the compiler cannot deal with that very easily. So sometimes you don't have errors unless you play the game. It's kind of annoying, and I prefer this one. This is just a preference. I believe if I was used to the Godot script, I would prefer Godot script. But one thing that is very interesting here is that if I have a Godot script and I have a C# script, they both work together. So that's nice. That's a very nice thing from the engine. I guess when Unity had the JavaScript, it was a time that they had 3 languages, and then they just ignored their own language and they stay with JavaScript and C#. At that moment, it was very difficult to communicate between the JavaScript and the C# script. It was not very compatible, and then eventually they just ignore the JavaScript. C# is more efficient because it's not the language is compiled and it's not interpreted in real time. So it's a little bit more efficient. Of course, in this case, you don't see any difference. If all of this was Godot script, the game would run the same. But if I want to make a, I don't know, an open world, GTA 7, whatever, you would feel the game heavier if the language was not efficient. Of course, my style of coding does not allow that, because it's very bad coding. I believe my style of coding is not very efficient by itself, no matter the language. So yeah, C# is hard or easy. It is what it is. When you get used to it, it's not there anymore. It's like speaking a new language, you know. You construct your sentences and you pass your ideas, and that's the important thing. Thinking about what needs to happen first and after and after and after. That's more important. And then translate the ideas into code. I don't know. That's the easy part, I guess. My problems are not language here. My problems is, let me define exactly what I need to do in which order to the game to happen, you know, correctly. So I believe this can be also programmed with C++, or the Godot engine is C++ behind the thing, so I can actually have C++ scripts also, but I'm not sure about that. What is the best channel to start learning C#, like Brakes, if you know him? Yeah, of course I know Brakes. I learned a lot of C# from him when he had the Unity tutorials, and he came back with Godot tutorials, but is using the GD script. So, but anyway, if you know, he returned. Yes, he returned. Brakes is back, but he's using Godot script, and which is kind of nice in my point of view, because he already explained a lot of stuff in C#. I passed to this program and it was very easy to adapt to Godot because I already knew how to use C# in Unity. So I believe if it was just translating its videos from Unity to Godot and the code is the same, I believe it wouldn't be adding new things, you know. But at the same time, there is a lot of stuff in Godot script already in the internet. So yeah, he has the luck of having a lot of followers already. So immediately after he released the video, I'm back, it went millions of views, and everyone was talking about him. But I don't know, good YouTube channels to learn C#. I don't know, man. I learned from him. I learned from another guy that is called I need to look at my YouTube channel. Oh, I cannot open because it's not the same account, and I will break the stream. Game Dev Guide. Game Dev Guide YouTube channel. This guy. But this guy, this is hardcore. This guy is not easy, you know. This guy is not easy, but it was one of the best ones for me. This guy unlocked this one, the event system he has here. I'm using in this game. The save system he has here, I'm using in this game. But I needed to update it because this was I don't know where it is right now. It was an old a legacy way of doing the things, not very secure, so I needed to update mine. But anyway, the main thing of the logic. But this guy is like, he explains the idea behind it. He shows some code. But when I try to implement the event system he has here, I was like 1 week to understand why I had the errors and whatever. And when I finally found how to implement this, because it doesn't show you everything line by line, and yeah, it was very, 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 very hard to understand. But as soon as I understood, it was like, you know, my brain was like, oh, so much knowledge. You know, the Matrix, when they inject information inside the brain, it was like that. But it took me a week, not 5 seconds. Anyway, this guy's good. I don't have here the Code Monkey also is very good, but I don't think. Yeah, this guy is Unity, and of course it's C#. In terms of Godot, because I'm a teacher and I need to teach game making or game design or whatever to art students, they are not coders, and I need to be very comprehensive on explaining how to do very simple stuff. I did some tutorials, so I have some of them, but the main audience is not programmers. This is too basic for programmers. But if you go on my channel, I have how can I go to my channel, my videos? If you go to my channels, I have here playlists, and I have here the Godot to the C# for beginners. And this playlist you have, let me see, from installing Unity to publish it in itch.io. So you build a little game, a shoot 'em up game. You build a little shoot 'em up game, so you kind of grasp the mechanics of adding stuff, removing stuff, moving stuff, you know, colliding stuff, writing things in the screen. So you can kind of follow these ones if you want to learn how Godot works and how you program it in C#. This is not the best tutorials. Maybe I will redo them again, because this was like, my classes were starting in 15 days after the Unity dropped the bomb. So I was like, I don't feel honest if I teach Unity, because I had this already done in Unity. I need to redo everything again in another engine, because yeah. And because of that, this was kind of, I was doing these videos as I was learning about Godot. So many things here maybe are not the best solution to the problems, but yeah, if you follow it, you will program a little game. Let me see if I can play a little bit. You will have a playable shoot 'em up game. Oh, this is explaining the publishing part only. So let's go to video 8, is the last one. Game structure. Let me see if I have here some. This is extremely simple, of course. Where is the game playing? So it could be better than this. I actually have the Unity version is much better with particles and camera shake and etc, etc, etc. But I didn't have time to do it. So if you want to know how to program this, yeah, follow these videos. And this is C#. Everything is here. Everything is explained line by line, idea by idea. And at the end of the videos, I always do this. I have the scripts. So you can just go to the end of the video and you will have the entire script shown. This was one of the things that the game dev guide, you know, to actually see the entire script, you need to jump the video back and forward. Very difficult to solve that problem. And I was like, no, I will put the scripts at the end of the video so everyone will actually pause here, copy everything, and it should be working at least. Then if you want to understand it, yeah, understand it by yourself, or listen to the videos. The videos are around, what, 20 minutes this case. They are small. They're kind of small. 2 minutes, 15, 17, 20, 20, 20. Yeah, it's around 20 minutes. So I don't know, 4 hours maybe. Yeah, if you want to do this, you will actually understand the logic of this sharp script. But I'm not the best one, trust me. I'm just another one. I don't know, maybe also the other guy, I did a game jam for him. Come on, I forgot. I did the game jam for him. I did the game jam for him. Lost Relic Games. Lost Relic Games, also Unity. And this guy is actually a great guy. He talks a lot about what is being a game developer and an indie game, working at home when you have time to work in your game, which is my case. He's actually a very great guy. But for example, the animator, the way I'm dealing with animators in 2D games right now is because of this video. It explains here a lot of stuff, some interesting stuff in terms of C#, but Unity. But yeah, once you understand, you can kind of translate the things from Unity to Godot. In Unity, for example, you don't have ready, you have start. You don't have process, physics process, you have update or fixed update. So the things have different names, but the structure is the same, the logic is the same. You don't have the delta, you don't need to insert the delta here in case of Unity, but you can call the delta wherever you need it. I don't know, there are some differences, but C# is C#, you know. The structure is the structure, and many of this mathematical stuff I'm doing here is exactly the same. It's like copy paste. Sometimes I go to the Unity version, I copy the script, and I just change what I need to change to use in Godot. So what? Okay. No, you are the best. Thank you, but I don't know. Maybe yes, but sometimes I look at my code and I say, oh, there is more interesting or more efficient ways of solving this. When you look at the code and if, you know, it's not very, I don't know. I don't like it, but it's the way I solve the problems. At the end of the day, I believe if the game is working, who cares, you know? If it has a lot of ifs inside ifs inside ifs. But if you go on YouTube, you see a lot of high-level coders saying, no, if you put one if inside the other if, this is completely wrong. And I was like, so how do I solve this problem? That I need to test two things, one inside the other, you know? Yes, I can have if and, but sometimes that is not the best solution. I don't know, because more complex stuff. I believe what I miss in YouTube, in terms of tutorials or lessons or whatever, what I miss in YouTube is having complex problems to solve. Because many things I see here is like, I don't know, build a shooter. So you have the shooting thing, but that's a tiny part of the entire game. And sometimes the shooter thing works by itself, but when it needs to interact with 1 million other systems, maybe the shooting script that is like 10 lines of code actually is I don't know, 300 or 400. For example, the example I can give you is my spaceship moving stuff up, down, left, and right. That is like 10 lines of code maximum, you know. But if you look at my script that controls the spaceship, it's not just 10 lines of code, because the thing needs to react and the thing needs to do stuff before other stuff, and then you have the animations, and then you have the sound, and then you have the fuel, and then you have the polar gravity, and the polar gravity is another script. And you know, when you start to build up on the game, that tutorial with a simple up, down, left, and right and jump, it's not enough. And when you actually want to go on YouTube, find someone that explains the entire process, I don't see that anywhere. So to solve a problem, you actually need to try, and you actually need to watch like 20 videos about many different things, and you are discovering those things along the way. So it's not very easy, not very direct, and that's why my series, my playlist is building the game. So you are always working on top of what's before. Oh, the first game I did, but this is probably very outdated now. The first game I did, I follow a tutorial on Please Brain Works. I will remember and I will tell you, because it was kind of this. You start from the beginning to the end, explaining everything. And I did my first game following those guys. I'm not remembering the name. I will remember and I will put it here. So you ask another question. Where are you from, teacher? Spain? No, I'm not from Spain. I'm from Portugal. I don't know if my English accent looks like a Spanish speaking English. I believe not, because I have Erasmus students that are from Spain and they don't speak English as I speak English. So, but I imagine that out of Europe or out of the Iberian area, Portuguese people or English people, Portuguese people or Spanish people speaking English would sound the same. Yeah, Portugal, north of Portugal. Walker Boy Studios, I believe Walker Boy Studio, something like this. Yeah, I learned Unity from these guys like 15 years ago or something, or 10 years ago, 10, no, more than 10. They have your learn, they have your course, learn Unity. This is like version 3 or whatever. Okay, it's not secure anymore. Oh, that's a shame. And they had Unity 5. This doesn't exist anymore, but they had what I liked in these guys. They follow the project along, and they have the JavaScript that I already knew how to use, and the C# version of the same thing. And I don't remember which one I was following. I guess it was this one. 35 videos. And they have here a lot of stuff. This is, I actually learned project settings, script setup, code structure, keywords, comments, and they have everything very detailed, as I do in my videos. So I was inspired by these guys somehow to explain everything in detail at least once. So you have there the option. But this is more like code. But what I liked in these videos is that they don't explain variables with random variables, you know. They explain variables using things that you need to use in your game. So let's explain how you can increment your life or decrease your health, you know, things that you actually use in games, and you kind of relate immediately what a variable is when the example is what you actually need for a game. And if you go to see random coding variables, sometimes the random coding tutorials or lessons, sometimes the variables used are kind of generic. You know, let's talk about an integer, and an integer is like a number, and let's say int a equals 7, and we're like, okay, a equals 7. What is a? You know, you cannot relate. But when the tutorial says life equals 100, and now let's decrease life, and let's do a method called decreasing life, and we say life equals life minus 30 or whatever, you kind of start to understand not only the code, but also how to implement that code in a real game scenario. And that's what I like of these guys. They explain the things with names and with game related examples. So also a very nice thing about, but this is very dated. Let me say, this is in Vimeo. The videos are in Vimeo, and they are from what? This do we have here? 9 years ago. So they are very, 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 very old. So completely out of date. Anyway. Not the accent. When I see your YouTube language, it's like, okay, Spanish, okay. Yeah, not Spanish. It's like, no, we are from Portugal. I'm from Portugal, sorry. I only went to Spain in vacations, south of Spain, when I was a kid. And I went to the north one time as we were presenting a schoolwork north of Spain, and then I didn't went to Spain more than that. So where were we? Rotating the spaceship in the beginning. So I press play. Let me see these bugs, if these bugs are related to the problem I need to solve. Object reference now set to an instance of an object. Which object? Level progression, no problem. And another one, a left panel computer. Okay, not a problem. This is not related to the problems. This is happening because I'm playing the level directly instead of inside the game. The level will only link to those objects if it starts from the menu. Another thing, that maybe a level should be played normally from wherever. But sometimes to solve those problems, you need to write a lot of code to check if the thing is there, you play. If it's not there, you throw an error or you ignore. And you look at the script, and 30% of the script is avoiding stuff because you need to test the level. And I kind of don't like that. I prefer to deal with the console full of errors, because I know that in the final version no one will play this level without being in the menu, because that's impossible, you know. So I prefer to have cleaner scripts instead of dealing with check the errors code that I actually don't need when the game is ready. So yes, I can implement that. Yes, I can clean that at the end, but imagine cleaning. How much scripts do I have right now? At this moment I have 54 scripts, at least, in the main folder of the scripts. Then I have the UI with 3 more, the tools with 1 more, and slot screen 2 more. Save system is like 10 scripts, event system another one, and sheet codes another one. So I have like 70 scripts. If I write a lot of code to avoid errors, and then I need to clean from that specific code from 70 scripts, this is a waste of time. So play, wrong play. It's not this play. I'm playing the game. Not it's not what I want. I want to play this level only. This has two different plays. Play the scene you are working on, or play the entire game. So it doesn't start rotating. It works. So okay. The problem is the plays no more errors. So okay, it's the same errors. So I believe the problem is, where is the spaceship? Spaceship is here, script is here. We are sending the rotation number. So the rotation number is here, start spin rate. Start spin rate is sent to the rigid body. Maybe this math F, whatever, it doesn't work. Let's print this and see what we have here. Copy. Godot print. Let's go to Godot. I need to start the game in window mode so I can see what's happening here. F6. Okay, minus 0.698 whatever. So this is actually is not 0. So it should be rotating. So if it's not 0, that means that this is actually working. But sending this number here this way is not. So we are talking to the rigid body manager and we say set start spin rate with that 0 point whatever. Rigid body manager receives that here. Oh, of course it is not doing anything. It's empty. Come on. Come on. I need to set the angular velocity with that number. Yes, it's kind of this is equal to spin rate. I believe this will work because I will put the spin rate inside angular velocity, but angular velocity maybe I need to put inside angular velocity, and angular velocity no physics calculations. This happens in the beginning of the physics process, and we say angular velocity equals whatever it is inside the rigid body. Okay, so we set the rigid body. I believe it's working. Let's play and see. Yes, it is rotating. It's not the right speed, but it's rotating. I need to change the way of how the polar gravity is calculating the attraction, because technically with zero drag and a constant speed, which is what we have, the orbit should stay the same. I don't have drag. Ship rigid body has 0 drag and 0 damp, so nothing is impeding it to move, but somehow it changes the orbit. It's If it doesn't need to be a circle, but when it starts and it's like an oval, it should stay there forever. It's what happens on the other game I did, sorry, in Unity. So if I go here, let's go to the other version, to the old version of this game. Can I mute this tab? Mute site, okay. So in the old version, come on. I like more this start screen, so, but then I need a menu. First level is just to go forward. I need, this doesn't allow me to choose the level, so let's stop here. Mission complete. Second one is go forward. So the first 3 levels just to teach how to maneuver the thing. Stop inside, thank you. And now the third one is to rotate and use the main engine only, no thrusters, so we kind of need to brake with the main engine. Okay, now it's the thing I was talking about. No drag, no changing in speed. The spaceship should be always in the same route, so it's always passing on top of the trail. And this is what I want to do in this level, but I'm not, my polar gravity in Godot is not working the same way as this one, so maybe I need to go there, copy paste the code, and to go to a higher orbit I just need to go forward in one place, like here, a little bit, and now I'm high and I'm low. Now I need to go forward again when I'm in the higher orbit, so forward here just a tiny bit. I believe a NASA astronaut would play these levels at the first try. And if I stay here for 3 orbits, this is what I want to program today, is to have like detecting, I need to detect the orbits in a specific altitude. It's not yet because here I'm outside of the thing. Oh, it's counting, so this is enough. But this polar gravity is working, but mine is not. Oh, sorry, stop. Let's, yeah, leave it here working if I need to return. So I guess I will just open the other script. So Adam says, I'm 18-year-old and I don't know if we have the same education system, but we have what is called BAC, and it's like the final test, and based on your grades and your division you can study. So I'm a computer science student. What is the best special? I don't know. You are from which country? Because I only know European systems, more or less, and mainly Portugal. And I never, that here we also have at that age, I remember that at that age we finished the 12th here, and then we need to choose the next school. Oh no. From 9 to 10 we need to enter a different like an area that was more or less specific to what we were like to be in the future. And some grades had some influence in some schools, but at 12 here, at the end of the 12th year, went to university, and in the university the grades can can tell if you enter or not in the school. But it depends. Art school is kind of easy, you know, and kind of art school and maybe computer science maybe here is more or less easy to enter. The difficult ones are like to be a doctor or something like that. I don't know the. I don't know. I need to search this. Let me search in another screen because I don't know what's going to happen. Minimum. No, I need to talk in Portuguese to Google. So oh, it's our system goes from 0 to 20. And you need to have an 18 to enter at this point. So this is a lot. But it's not very difficult to have an 18, I believe. Oh, this is 21, 22 was 18 again. Because technically this is the grade of the last student that entered in the previous year. That's the new standard for the next year. So if the students are getting worse, this number goes down. So you say, so I'm a computer science student that I'm from Tunisia. Our education system is like France. Well, I'm sorry, I don't know the details of the French system. What is that like score? Yes, is your medium is the average score you had in all subjects in the 12th year. And then you have like exams, like national exams, and some schools want specific exams for you to enter. So you need to check the system in your country. I cannot tell you more than this. You need to know which kind of subjects you need to study and what are the minimum grades to enter. But yeah, I cannot help you a lot here because I don't know the system where you are. But not all the schools work with the same numbers. That at least here in Portugal, not all the schools work with the same numbers. It depends on if it's a public school or a private school, and it depends on the number of students that they can get in each year. For example, a small school with 2 classrooms cannot have more than 40 students, and a big school with 30 classrooms can have like 1,000 students. So when you have 1,000 available entries, yeah, the number is 18, but if they have enough space and the next student is a 17, it will enter because they do not block the students because they are below that number. If there's vacancy for them, I guess. Vacancy maybe is not the best word, I don't know. So that's why the grades can go down. You know, the grade is 18 this year, and you have 20 slots. But if you only have 12 new students, and the worst one is like 15, next year will be 15, because they don't fill all the slots, and so it depends. But this is here. In our country, I don't know. You need to capacity. Yes, thank you. Yeah, in your country, I don't know. Talk to your teachers. Ask them. Don't be afraid of asking. Yeah, about the things, and just ask, get informed, and act according. Is the exams in Portugal set 20 or 100? 20, 0 to 20. This is the grade system here is from 0 to 20. Yes, like 2020. So if you have 0, you fail. If you have 10, you pass. But you are a very, 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 very bad student. And if you have like 16 up, you are a very good student already. And 19 up is like the next teachers, you know. Yeah. But this is just the final number, and it cannot have decimal places. It needs to be an integer number, and not 16.5. That does not exist. We can evaluate like that, but the final number needs to always be a simple number. So when I'm grading when I'm grading the works of my students, I use very different scales. There is a work that it's very easy for me to evaluate from 0 to 300 because the work has 300 things to check. And so I evaluate each one of it, and then I calculate the 0 to 20 relation. And the only thing is, at the end, it needs to be from 0 to 20, but we are allowed to evaluate as we want. What I see that is more difficult in the evaluation is find the correct things to count and to calculate, so you have an honest grade. And an honest grade is a grade that actually puts on top the ones that actually know how to solve the problem, you know. And so I'll always try to go as much technical as I can. I teach in art, in an art school, and art is very subjective and it's very difficult. If I don't like it, I will grade bad the student. I cannot do that, you know, because it's not my style, because it's not in my likings. But art is art. It's very difficult to do. So sometimes we need to deal with those kinds of situations. And well, for me, if it's consistent, even if I don't like it personally, maybe that it's a good work because someone will like it, and I need to evaluate consistency, for example, instead of the style. I don't know, you know. So when it's science stuff, it's very easy because 2 plus 2 is 4, no mistake, no ambiguity is correct or is wrong. It's very easy to evaluate. When we go game design, art, styles, and the things start to get a little bit difficult to grade. But so it depends. In this case, I teach games, I teach sound and video, so I go, is the sound correctly recorded? Is the sound correctly mixed? Is the video, the image is properly exposed, properly focused? The framing follows the rules, etc., etc. The color balance is, you know, the equalization in sounds is coherent from the beginning to the end. If I evaluate that, I'm actually grading higher a work that looks like a film, you know, is balanced through the entire thing. Oh, it's a film about bananas. I don't like bananas, so yeah, but it's a good work. You know, that's the problem of the art teachers, is evaluating what's behind the technical parts behind the art that are not the things we like. The final exams, BAC, starts after 15 days. From today, well, you need to study. Start studying. Yeah, here is the same, I guess. It's 2 weeks for the end of the day. At the end of the year. So I believe I have students. I already had students from Tunisia. I'm pretty sure. I don't remember. I always have like 10, 12 students per year from other countries, so I teach for the last 16 years. So it's a lot of people. Anyway, let's try to finish this this problem here. So, oh, I was about to copy. Let's get the Unity version, the polar gravity from the Unity version, and see. Let me go here on my folders, Unity games, free return trajectory, assets, sprites, not sprites, scripts. Polar gravity. I have here some kind of polar. Yes, I have. Let's open the polar gravity from Unity. Polar gravity from Unity. So visually, as you can see, the script is very similar. What's changing here is the name of the methods and the inheritance and the libraries is the same thing. So let me see, where is the polar gravity stuff? Fixed update for each game object. I will attract, I will calculate the distance, and I will get the direction normalized, and then I will add, oh, I'm using this, I'm doing it very differently. No, it's the same. Polar gravity from Godot. Let's see, where is the calculation is here. So the polar gravity here, it does the same thing, gets the direction of both objects. This is to set up the center of gravity of the object. It doesn't affect the gravity. Oh, this is the different thing. Length square, directions, length square. I calculate the direction here differently. Let me see how I do this. Distance is distance from one to the other. Oh, but what's happened inside this method, I don't know. And what's happened inside this method, I also don't know. So this is my problem. I'm using something that already is made inside Godot, in this case inside Unity, and I don't know exactly how this calculation is being made. What is the distance inside vector2? It's just a linear distance? Maybe it is, and here is not, because the length square. This direction is from, or maybe this is just to calculate the direction of the vector, so where it's pointing, but the distance will always be 1 because it's normalized. And then force magnitude equals to gravity constant, so some kind of number that I can adjust for everyone, and the gravity is the same in the entire universe, times the mass of one object multiplied by the mass of the other object divided by distance square. So, and here something times something is the same thing divided by distance square. This is the distance square. Maybe this is maybe I can copy this to the Godot script and try to adapt to the Godot code. And let's see, this is, and then apply the force at the end. Gravity equals force. So in this case, I'm putting all the forces inside a list of forces, so every planet attracts a little bit into one direction, and then I apply at the end that list of forces. Here is not a list, is a I'm calculating a vector directly, so it's technically the same thing. It's not technically the same thing, but the output will be the same. Let's paste here what we have from Unity. And now let's try to translate this into Godot. Yeah, nice to meet you. It's 11:29. Here is also 11:29, so we are in the same. 11:29 in my country, so nice to meet you, teacher. By the way, I subscribe your channel. Thank you for the subscription. And I like the video. I will come back. Yeah, I always stream at this time because it's when I have free time to do it. So if being late is a problem for you, it will always be late. But you can check the rest of the video tomorrow. So see you. Then thank you for watching. And study for the exams before. So, polar gravity. Bye-bye. Polar gravity. I have the other the transform is to get the position. Okay. Other transform. I get the transform. This is not necessary. I already have this. Undo. Why do I have the other rigid body? Oh, it's just to get the mass of the other guy. Okay. So I'm using the transform to get the position, and I'm using the other rigid body to get the mass. In Godot, I don't need to do it, because if I call the other rigid body, it automatically has the position of the node. So I also don't need this line. I already have the other rigid body and the other position. So these lines are not necessary. Now, float distance, vector2 distance, and this is my problem. I don't know. Yeah, as you can see, vector2 in Godot does not contain a definition for distance. And this is give me a number from a position of one of the objects to the other object, which is what I have here. I have here the global target position minus global position. Oh, I believe this needs to be like this. It's the same technically, but this is to be affecting only this one. Technically, I believe this is the same. Mathematically speaking, this will be the same. Let's see. Let's do a 3 minus 2 plus 1. So 3 minus 2 is 1, 1 plus 1 is 2. 2 plus 1 is 3. 3 minus 3 is 1. So it will be the same. The parentheses don't do anything. Okay. Now, distance. This is the distance from one object to the other. Okay. We have that here. But here, distance squared returns the square length, magnitude of this vector. This method runs faster than the vector to the length. Okay. So prefer it if you need to compare vectors or need the square length for some formula. So this is faster than length. Okay. This is faster than length. But this is the length anyway. Because technically, if I prefer this one instead of the other, this is just a direct distance between two vectors. This is the distance from two points in space. Okay, so the same as here. So the distance is the result of one position and another position. So this is the equivalent of this. Distance squared is what I need. So I'm using distance here. So let's copy distance squared down here, paste. Transform position, other transform position. So here we are going to change. This is normalized. I already have this somewhere here. No, this is force. Transform position minus transform position. This thing is a vector 2. And other transform position minus my position is the same as this. So is the direction in this case. Copy. So this is direction. Direction. And now I need to copy the mass from the other guy and my own weight. So the parent rigid body mass goes here. And the other rigid body mass, the target mass, goes here. And instead of adding this to the items list, I will calculate directly as I did here. So vector 2 force equals to, no, gravity force plus equal to whatever. So gravity force plus equal parents can be removed. Okay. So this transform position, I don't need this line. So technically, the other polar gravity works this way, and the polar gravity I did for this time, I did this like 1 year ago, so I don't remember really how did I get this, whatever. Okay, so force magnitude equals to gravity. Oh, but I apply this force magnitude where? Force. Gravity force. Let me see where I apply. So add force is all the items times the delta times mass multiplier. Mass multiplier is probably some kind of fixed number. Reset body manager, polar gravity force equals to gravity force. So what's happening here is, for each target, if I have 10 planets, each one will attract a little bit. For each target, I will calculate the direction. Let me comment this thing, distance square. I'm using distance square. Down here, yes, I'm using distance square. So I will comment this part. This is the Godot version of polar gravity. And let's see if this works. Save. Probably will not work, but I don't know. I don't know. Let's see. It went forever. Let's put a lower number, but maybe it's too strong. Like nothing, 0. We should fall into the planet. It should fall into the planet. Let's see. It doesn't fall into the planet, so it's not working. Nice. Nice, very nice. So. Or maybe it's working, but the force magnitude is kind of giant number. Where is the force magnitude? Oh no, it's not. This is one. This is the one that is actually very big. Gravitational constant. Where I'm doing that? Yeah, it's here. So I'm force magnitude. So probably I just need to multiply by this gravitational constant. Direction times the force times the gravitational constant. Let's see. Let's see if the spaceship falls into the planet now. Still not falling. Well, it's moving. Yes, it's falling. Yes. It's actually working. So let's do 200 of speed, and let's see if the thing goes around the planet instead of falling. Maybe 200 is too much, and maybe that gravitational is moving. Oh, come on, there's no key for full screen. Oh. It's actually moving, I guess. Yes, it is. Very slowly. I need to make it faster. So let's go increase this gravitational constant like 10 times. Let's see if the thing works. Yeah, it's falling a little bit more. Okay, I'm liking this. Let's go faster. 1000, maybe more, through 4000. Let's go faster to see if we don't too fast. Okay, let's give it more speed and more gravitational whatever. Where is the number? Do I have that here? No, that's inside the other script. Let's go. Five times faster. It's 5 times more. Save. Play. Okay. A little bit less speed. So it stays in a circular orbit, not some 3000. And let's see if we have the okay, maybe just a little bit more, 3200, and I can make it a little bit closer. So this should be enough to test what I'm trying to test, which is the orbit should be the same. Oh, come on. Don't fall. The orbit should stay the same if I don't change the power. Okay. Now it's too much. Let's go manual. I'm lost in space. Where I am? Where am I? Oh, I'm here. I was actually to recover, but then I crashed. So let's go a little bit slower. Okay. Okay. A little bit faster. This will not be easy. Let's go here. Play. What I want to do right now is to make sure that it stays in the same orbit if I don't do anything. But this actually needs to be in a kind of stable orbit. Oh, when it's close to the thing, it falls really fast. I need to brake, so the engine should be pointing forward. And now I will fall again. Go away, go away. This is not working because it's very easy to get extreme forces when we are very close. So maybe this is not the correct way of math the thing. Okay. So let's see if I'm stable. I need to pass where the mouse is in the next turn. I believe I'm going down and it's not stable. It should be here. So this calculation it's not working. This calculation is not working. But the other one was also not the best solution. I don't know. Let's look again to the other one. So let's go line by line again to see what's happened. Let's comment every line. So this line, we get the other transform. Now this lines doesn't matter, it's just to get the objects. Okay, here we do distance. Distance from planet to ship. Other is the planet, transform position is the ship. Okay. This variable v, I don't know why v, oh, it's a vector 3. Okay, it's a vector. So the other vector, the vector is equal to the position of planet minus the position of planet minus the position of ship. Normalize, meaning, let's say if the vector is like 4 to the right, it will be normalized to 1. If it's up 4, it will be normalized to 1. If it's diagonal, it will be normalized to the distance to whatever circle is around 1. So this is a number between 0 and 1. So technically this represents the direction. Direction only. So I have the distance. Technically this is the distance. Well, this can be negative and distance is always positive, so yeah. Anyway, direction. So next step of this calculation is to add to a list of vectors. What do we have? We had the direction times one mass times the other. So both masses will be multiplied. So if this is 10 kilos and this is 2 kilos, this will be direction times 20. Okay, 20. This is a multiplication, so it will be direction is xy, x times 20, y times 20. Okay, so direction times mass is not math of both, is a mass product divided by the power of the distance. And the distance is a linear distance. It's a positive number always. And we add that numbers to the list. And we do this for all the objects that have polar gravity. After we had all the objects that we have in the list, what do we do with this list? This is divided by power distance. Okay. After that, after we have all the items there, so one could be pointing there, another could be pointing there, another could be pointing there, no matter how many things we have that are attracting each other. And we are actually calculating these attractions using its own mass. So if we are heavy, we fall more. If we are light, we fall less, technically. I'm just not sure if we are in this list. It doesn't make sense because we would be attracting ourselves. This target comes from where? This target comes from, for each object in target. Okay, target is made where? Okay, if the game object, yeah, okay. So we don't add ourselves to the list of targets. Okay, this is kind of logic. So after everything, this is the magic. What I'm trying to do here, just to clarify, is to copy the polar gravity I did, I don't know, 3 years ago or something in Unity. In Unity, the polar gravity works correctly. In Godot, it doesn't work correctly. So this is the script from Unity, and I'm trying to remember how did I solve this. So after we have all the directions with the correct force or the correct strength, whatever, we pick up the self object and we add a force, get main vector items. Get main vector, what does it do? It will cycle the entire list one by one. If there's no objects in the list, it will not do anything. So it doesn't throw errors to the console. Then it starts by resetting the entire vector, axis by axis. So it creates a new variable for each axis, and then for each thing that is in that list, it will increment that direction. And at the end, it will do the average. Oh, I'm not doing the average. So all them together divided by how many they are. So this is the average. I'm not doing the average here. I'm not doing the average. I'm just incrementing them and then I'm applying it. But technically it's the same thing, no? If I have one that pushes that 10 and then I have another one that pushes here 10, it's 0. Add 10, add minus 10, returns to 0. So technically it's the same thing. Yes, maybe no. Let's do a simulation here. So let's imagine that we have one vector that is 3, the next one is 2, and the next one is minus 6. If I increment this, I will have 3. The next one will be 5, and 5 minus 6 will be minus 1. So this is minus 1. Minus 1. Now let's do the average of this. Calculator, 3 plus 2 plus minus 6 divided by 3. Oh, it's not the same number. No, this is not correct. Minus 6 gives 11. No. Let's sum all these numbers together. Minus 6 minus 6 plus 2 plus 3 equals minus 1 divided by 3 equals 0.3333. Yeah, it's not the same number. Of course, it's not the same number. So maybe that's where this fails. I'm not doing the average. I'm not doing the average of this sum. So the number is, I'm just adding them together. I'm just adding them together, and then we do the average. We return the average. So we add force, the average of all the items we add force, add the average of all items, of all planets, whatever, times the frame size times the multiplier, mass multiplier is like a constant gravity, whatever number it is, to mass multiplier is 10. In this case I'm multiplying by 10 because the number is too low. But technically times multiplier, or let's call it global gravity multiplier. So this is the number that makes the universe equal everywhere. If I want a stronger universe, I just need to change this number. So distance from one to the other, position, direction of that distance, then I multiply the direction by the mass product, which is both masses together, and I divide that by the distance, the power of the distance, and then I average all directions. But in this case, where I don't have more than one, I just have one. I don't need to do average. So technically gravity force is only one. there's no average to be calculated, because there's no, it should work without the average if it's just only one planet. Yep, pretty sure. So I sent this to the polar gravity force, and the polar gravity force, sorry, rigid body manager, rigid body manager, polar gravity. Polar gravity force is being calculated with the engine. So this is the engine's force, and this is what comes from the polar gravity force, and final force is being applied to the rigid body. So applies a position force to the body. A force is a time dependent and mean that to be applied every physics update. Okay. Position is the force from the body origin in global coordinates. Very well. I believe it works similarly to Unity's version of add force, so if they are different, they can be a little bit different, but technically the orbit should stay the same, not change. So very interesting. This is the Unity version of the polar gravity. I have here another thing, auto orbit. Oh, this is to automatically detect how much force it needs to have to stay in orbit in the beginning. So I don't have that yet. It is in start, so that's not a problem. Create a list, reset the direction for each object, get the distance, get the direction, calculate the force for each one, and then average the forces times fixed delta time. Maybe this is something that I don't have in the other side. Technically, I don't need this, because if I'm already inside the fixed update, I'm going down here to go up here, and because this number should be the same every time, but maybe it's not, and that's why I start to get drift. So let's do the delta also in the other one. Blah 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 blah. So whatever I need to apply times delta times multiplier. So here times delta. And now I need to multiply this by 10. I don't know, 10. Let's do a fixed number here. Let's go to Godot and see what happens. Maybe that's the delta was the thing that was missing for this to work more consistently. I'm not sure. I don't know. Too much force now. Let's go 3000. Let's go 300. Because the time the delta will be a very small number. Yeah, it's attracting, so that's good. We just need to find the correct number here to have a circle. a little bit more. I didn't break. So can I escape from here? Yes. So let's see if I can get a very low orbit circle. I will explode. This was what? Too much? I don't remember. Okay, I believe I'm in a circular orbit, more or less. A little bit speed here. Oh, I should have stopped there. I need to speed up on the higher orbit and slow down on the lower orbit. Okay, I will start to fall again. Let's say, see if we get captured from here. So this is a very low orbit, but I believe it's not stable. I believe it's not stable enough. Let's go. Speed. Speed. Slow down. No, this attraction is not working correctly. It was much easier to have a circle in the other one. Or maybe I'm just not heavy enough. Let's go 1000 and see what happens. Let's go 1000. Yeah, maybe I'm just not heavy enough. I stop. Yeah, but when I'm far away from the planet, it takes a long time to start falling. And then when I get close to the planet, the attraction is a little bit more violent. So this is not the solution, or if this is the solution, there's something missing here. Let's do the average. Let's copy the same way of solving the problem. So gravity force is what we are incrementing, as we are doing it here. So we are incrementing the items. The items here are vectors. Do I have vectors here? Gravity force is a vector. Yeah, I can do the same thing. Let's do the list of vectors. In the other game is a vector 3, not a vector 2, but it's the same. I'm not using the Z axis in the other one. So that's not the problem, pretty sure. This will be called what? What do I call it here? Items. Okay, items. Items. Let's do the same. Equals to a new list of vector 2s. Vector 2. We create a list, we initialize the list empty. every time we need to calculate the attraction. So now, instead of incrementing whatever is happening here on the gravity force, we are going to add this to the list. So this gravity force will be added for each. I need to reset the gravity force. I need to reset the gravity force every frame. So every frame, no, every element. So here goes blah, blah, blah. Delete. We will reset at every target. And we add that to the list. So item, add whatever calculation we do. In this case, items dot add gravity force. That's it. If the target is different from the rigid body, because the target will have all the bodies, so it will not add itself. As if closes where? Okay, it will not work for itself, of course. I will not attract myself. Or else I would be a black hole, because my gravity will consume me. Well, I don't know. Anyway, but black holes are not attracted to themselves also, so maybe I was completely wrong. Okay, we had the gravity, and then at the end, before we apply that to the rigid body, we need to get the average of this. We add the force is the average, so we get the main vector is the average. Let's do, I believe I can just copy paste this and it will work. Copy, paste. I just need to change it to capital X, capital Y, capital Z, and then return the vector 2. This needs to be vector 2's because we don't use vector 2. I don't need the Z. I don't need this one. For each vector 2 position, it will vomit a vector 2 with the average of X and Y. Return a new vector 2. Empty, so 0. Get main vector. And here we have a rigid body, blah, 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 blah. Let's comment this one. Equals to get main vector of items times whatever we have there already. Copy. Paste. So now we are doing the average. We are adding the things to a list and doing the average. That I believe is not a problem, because we only need to calculate average if we have more than one. If we just have one, the average is that one. So I'm not believing that this will work. I need to accelerate here. Oh no, I'm going out. Let's add more speed and more weight. Because I want the thing to happen faster. More weight. 50,000. I believe I pressed the wrong play. Yes. Let's see. Strangely, the mass, object mass, it's not affecting. $19.99 whatever. Enter, play. Oh yeah, this mass is not being applied. Okay, so let's see, let's find the bug. Why this mass is not being applied? Object mass is being sent to the polar gravity object mass on enter tree. Polar gravity object mass, polar gravity object mass, polar gravity, no, rigid body, no, polar gravity. So I'm sending the mass directly to the polar gravity, but am I changing the rigid body? I'm not changing the rigid body. I believe that's not important because I'm not using Godot's force stuff, I'm using my own. So if my polar gravity has the number, where is the mass? Polar gravity object mass. Where is object mass? Oh, sorry, wrong script. Object mass is here. Object mass is being used. Parent rigid body. Parent rigid body. So the object mass is being sent to the rigid body. Yes, it is. In the ready function. And then we use the parent rigid body mass to calculate the attraction. So technically the number is there. And if I'm multiplying that big number with another very big number in the planet, this should be a very big attraction. Eventually, polar gravity, reparent rigid body mass. The rigid body manager has mass here. Is mass being used? No. I don't use this variable. Maybe I use it. No, but I'm not using this mass anywhere. So this doesn't need to exist. And here I just get the rigid body and I don't change anything from here. This is just a centralized way of accessing the rigid body. Rigid body 2D, no mass, no mass, no mass, just, oh, maybe mass, yes. I change the mass of the rigid body. Set mass, this comes from where? From ship. From ship, and from polar gravity, no set mass. So technically the number is there, and it's actually there twice. So this one sends the mass there, and the polar gravity also sends the mass to the rigid body. Manager. I don't like this. I need to make sure only once the number is set. So the ship talks directly to the rigid body manager. That's good. The polar gravity talks directly to the rigid body. I don't need this here, because the rigid body already has a mass. Am I using this anywhere else? Yes, I'm using this to detect the direction only, the rotation or the velocity. And I add this to the target of rigid bodies to attract, and I get the position, so I'm not changing it. I can read, no matter where I am, I can read the thing, no problem. But I cannot change it. Okay, I'm not changing it from here. I'm only changing it from the other one. I guess this doesn't change anything, but let's see. Or maybe I changed anything. I changed something, because now it falls very quickly. Okay, we have something here. It's weird, because if I put the same number twice in the same variable, I don't know. Let's get, oh, sorry. Let's get the ship again. Let's lower this 10,000. And let's see if this plays normally. Okay, let's go 1000. It's kind of following the same place. Let's go 1. Yeah, this is not being applied again. Or it's being applied too late. Maybe the other one is calculating the attraction with some different number before this being actually applied. object mass is being sent to the polar gravity first. In polar gravity, this is enter 3. Okay. In polar gravity, object mass I'm not doing anything with this number. What? Oh, I'm using the set mass from the other one. Set mass. That's why this is not working. Set mass on this script. Find set mass. I'm doing the set mass in the ready function. So let's copy this line. Copy to here. I don't have set mass in this script. Let's put it here. So this is mass only, I guess. Object mass. And let's disable this line here. No more ship. It was already in the future. Okay. Let's go 1000. Now the mass is affecting something. Okay. 1000 also. Let's see if these numbers work better. I gain speed when I fall, and then I keep gaining speed. That's not very natural. That's an infinite energy glitch in the matrix. So yeah, keep this altitude, please. A little bit faster. No, I will fall. Faster now. No, this is not working. I don't know where is the bug. Well, it's not a bug. It's, the calculation I'm doing for the polar gravity is not the best. Let me check again this line of code. So average times the delta times the multiplier. This is the same. And this happens where? After the for each. Okay, after the for each, we get the average times the delta times the some number. Okay, maybe I can go bigger here, but this will be linear, so this means it just falls faster. It means that we can test the things faster, but the bad behavior will be the same. Yeah, I should be falling already. And now, no, this is not what we need to do. This is not this problem. We can keep the 100, but okay. So next is maybe this is what we have different. Or maybe not, because I already copied this. So the direction times mass product times power distance. Direction, yes, times mass product, so ship mass times target mass divided by math power distance squared to, oh, I have here a gravitational constant. Maybe this is what's different, because I'm doing that constant down here. And this distance is what? This distance is planet. Yeah, is a distance from the planet to the spaceship, okay? And this distance square is the same. I believe it's the same. But maybe I need to change this also. Let's comment this and do the distance as we did here. I'm pretty sure it's the same result. We can actually print it later to make sure. Oh, but distance does not exist in, that's why. Well, distance is what? Is length? Length Um, come on. And instead of transform position, we use okay, we have here another problem. Our direction is not normalized, and in the other one is normalized. Let's undo. Okay. So we need direction, and direction is what we already have. Copy paste. But direction in the other script is normalized. Yes, it is. So let's normalize direction. What we are missing is the distance square. Distance square is one vector minus the other vector is the distance between the vectors. Yes? Probably. So let's calculate that. Technically, is this. The direction is the distance before normalization. So if I put direction here, it should work, but direction could be negative. And a distance should be always positive. So let's go direction. Let's go math f dot abs of direction. Dot length, because direction is a float. Too much errors. ABS cannot be applied operands method group and float. No, come on. Why not? Why not? Okay, let's do it differently. So this is what we need here is the distance. So let's create a distance. Float distance. Though no, it doesn't exist yet. Equals to direction to math f dot abs of direction. dot length. And now we put the distance there. So this is always subtraction from one position to the other, but it's always positive. The distance is always positive. And now, what's the problem? What's the problem? Direction times. Okay, I need to close the parentheses here. Yes, this one is too much. Divided by the power distance. Direction normalized is a float. Okay. So let's recap. We are multiplying both v is the direction. So we are multiplying the direction by both the multiplication of both masses divided by the distance, the power of the distance. And here, direction I can normalize this there. Oh no, I can't, because I need the distance. I need the direction without normalization before. So okay, undo. Let's stay like this. So direction normalized times the multiplication of both masses divided by the power of the distance. Okay, now we have exactly the same thing, but in Godot style. I'm not sure about this. Let's see if this is working differently. Probably is behaving differently. Okay, let's go 1000, or maybe we can go 5000 and give it more mass. Strange. I put more. It's not falling. No speed. Well, it's actually falling, but very slowly. Let's stop the rotation. So we are falling very slowly, which is actually nice, meaning that we just need to adjust that multiplication factor we have here. This one. Let's go 10,000. Let's see what happens. Okay, 100,000 needs to fall faster. Save. Yes, I'm okay. Yes, I'm still alive. I want to solve this problem today, or else tomorrow I need to start again. You know, the brain works that way. Okay, now we are falling. Let's go. $2,000 in speed. Maybe more speed. Okay, let's grab it. Let's wait. 1,000. Let's see what happens if we reduce the mass of the spaceship. We should have less attraction. Yes, we have less attraction. Oh, it's working. Stable orbit. I'm pretty sure. Let's see if it passes through the mouse again. Oh no, it's not. It's going out of the screen. Oh, it's just a tiny bit off. But it's much better now. It's actually very similar to what I had in the other one. But it's getting altitude. You know, this cannot happen. Maybe I need to add some kind of drag to fake this, or some NASA scientist look at my code and says, oh, you are forgetting that thing over there. Well, the moon is looking beautiful today. Well, this is not the moon. This is a planet, a pink planet. I have a moon. Do you want to see the moon? This looks much better. This is behaving much better. This is behaving much better, but I broke the entire game because I changed the way of gravity works, meaning that all the levels that have gravity need to be adjusted to this new engine. But anyway, this is not yet working as I want. Let me see if the other level works properly. What did you add today? I had a button to show your comment. Much faster now. I'm trying to make the polar gravity be more consistent. Technically, if we have zero drag and zero changes in velocity, we should be in the same orbit all the time. We just go faster or start to fall if we have drag or if we have engines. And at this moment, if I don't do anything, I start to gain altitude, which is kind of not how real world works. So next time I will pass higher, and technically this goes against the Newton. See, a little bit higher. But the Unity version I had when I did this game the first time, it didn't have this problem. So I went into the Unity polar gravity and I just copied the code I had before, and I'm applying the same logic except for one thing that I don't control, which is how the rigid body behaves inside Godot is not the same as, so the physics engine in Unity works differently from the physics engine in Godot, and yeah, I'm doing the same math, but maybe I need to add something else. Maybe I need to fake the drag or something like that. I don't know. But if I fake the drag, that's another problem. You need to add resistance. Yeah, that's called drag in here. If I go here to the rigid body, I have here the damp in linear velocity and damp in angular rotation. In Unity is called drag. So damps the body movement. By default, the body will use the default linear in project settings. So this kind of stops the movement over time. I guess I don't have anything else here related to that. No. So, maybe the problem relies on how the rigid body works inside, and I don't know. I don't know where this script is, and I don't want to change it. So maybe I need to adapt my own to deal with this. And I guess this is happening only if I have a damp here. I can have a damp and see what happens. How much do I put here? Damp the movement. By default, the body will use the damp default blah 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 blah. Dampening it is linear mode, so you can set linear damp to be added or to be replaced in the body's damping value. So what, 1 is 100% damp, or is, what is 1? Let's see what happens. And let's play and see what happens. Yeah, I have drag now. I'm dragging through the sand instead of the emptiness of space. So 0.01. So technically I'm dragging just a tiny bit. Let's put the mouse here. Let's see if it passes in the same place. Now it's lower, so less drag, but this will create a problem. This will create a problem that I don't want to have. Drag means that I stop if I don't move, eventually. So when I'm going to the space station, if I go super slow, I will stop before reaching there. And I don't want that. Now I don't have drag enough drag. So 0, 1 was too much. So maybe 0.09. So save. Or maybe that could also no. No. The Unity version didn't have drag. If I just do a tiny bit to the side, it goes to the side forever. I can fake the thing. If I below some amount of speed, I disable the drag. So in the mission of the space station, I will not stop. But if I'm above some certain speed, which is orbiting a planet, I go fast, I have drag. I don't know. A little bit more, a little bit less. So 0.7. I wanted to use the drag not in specific levels but in the specific difficulties. So if you are in easy mode, you have a little tiny bit amount of drag, so it's more easy so to stabilize the spaceship. Now I'm passing exactly in the same place. So now I'm in a stable orbit. Maybe not totally there, but yeah, 1 pixel every 2 laps, every 2 orbits is not a problem. Yeah, maybe I need a little bit more drag, just a tiny bit amount, so 71. As you can see, this is kind of stupid. We are dealing with a very small something, and maybe it's just how the rigid body works inside. Because if the drag I need to add for the thing to work is so tiny, maybe the problem is, for example, I'm calculating the delta with a float, and the float does not have enough precision. But if I don't put the float, the thing doesn't work because I cannot multiply a double. Maybe it's just this problem. I don't know. But visually it's working now. This means that I can have, finally after 3 hours, I can start to make my game, my level of orbiting. I will not do it, of course. What I'm going to do is to fix the other levels that now have a very different way of dealing with polar gravity, so the numbers on the other levels will not work. Okay, so let's go to a lower orbit. To descend to the planet, I need to deaccelerate when I'm low, which is here. And now I'm in a circle. Yes. Now let's start to deaccelerate very slowly around the entire planet, and I will get lower and lower and lower and lower and lower. This is a very stable descent, but I can go like this. Very aggressive. Okay, low orbit, even lower. Even lower, around here. Okay. I accelerate when I fall. If the orbit is an oval orbit, I gain speed. So the drag is not working. I will purposely make an oval orbit. So accelerate here. accelerate here. Let's see if I pass in the same place next time. Yep, see? The drag is not working. The drag was working for that specific altitude, so no. No. That's not the solution. I don't know. I don't know where is the problem. Yes, it is. Trust me, it is a problem. It's not a problem, but I can show you in which case it's a problem. I will show the other version. So in the other version, this is the Unity version, so many years ago. The other script that I was using there. I actually need to play all the missions because in this version I cannot choose the missions directly. I just need to reach the 3rd level. The problem is that I don't have to stabilize every time. If I don't have drag, I don't have drag. I should be in the same perfect route. So this is the problem. If I don't do anything, I stay here. It's actually passing exactly in the same line every time. And if I accelerate a little bit, I go higher. Yes. I can stabilize it here. Oh, I stop. Stupid. Okay, I need to go forward the higher orbit and I stay there. This is how real spaceships works. Of course we have a little bit of drag in space because of atmosphere and etc, etc. But in my game of Godot, I don't have a negative drag. I have a positive. I have the opposite. I accelerate, which is bad, you know? I cannot accelerate because I do a slingshot. I lose energy every time I do something. There's no infinite energy. I accelerate in the wrong place, so now I will lose the level. Oh, okay. Maybe not. Okay, go a little bit lower here and accelerate here. I'm in the higher orbit. It's counting. Okay, let's go faster. This one I can accelerate the time. Docking. I guess I don't have another level like that in this version. This one is much more simple. Just do the thing and it's done. No, it didn't happen. Okay. You didn't try. I didn't try what? Ellipse? If I ellipse, the level ends. I cannot go out of that mark. Oh, but I can show you here. This one. The planet insertion. 10 orbits around this planet. If the thing is not stable, this level is impossible to win. Because every time I go slingshot outside of orbit, you know. And here I can deaccelerate now really hard, and I'm in orbit. I'm following. The thing is moving. I go after him because the gravity is pulling me correctly. So let's lower even more. Okay. Even more. Yeah, I can do 10. I will not touch it anymore, and I will not get out of this orbit. I'm in orbit. And let's speed up the time. Okay. 10, 11, 12, so on and so on. So I don't know. The physics are not working exactly the same. The physics are not working exactly the same in the other one, and that's annoying for me. End of demo. But I don't know. Oh, time is sped up. Anyway. So, this is the behavior I don't want here. I want to be in a stable orbit and just be in a stable orbit. Let me try the other. I changed the physics of the polar attraction, so maybe the other level will not work without me adjusting the speeds and the mass of the ship. But let's see. Yeah, too fast. Where is the other? Is the orbital? No. Test scene also. It will also not work. Did you already see this working? Did you see the thing landing and whatever? Nope. Okay. Let's see if I can show you, because ship mass 100. Let's see. Only popping. Yeah. Okay. Well, I don't know if I'm able to land because I changed the polar gravity. And maybe I will just crash. Okay. But this one is working better than the other. Anyway. If I separate in mid-flight, this happens. The second one does not get the same velocity and direction, so it kind of pops out and stays there. Pop. But now I can collide with that thing. Let's go around the moon and try to get it the other side. The camera does not zoom out, so I believe I will find it in a bit. Let's wait. Just a little bit more. No, I'm too far away. Let's give a little bit more of zoom to the camera. Whoop, maybe like this. Oh. This zoom thing is very weird. I will fall. Almost. I almost crashed. It's not rotating fast enough. It's difficult to control. I guess I'm in a circular orbit around the thing, more or less. Okay, let's try to land on the North Pole. Oh, wrong direction. Stop rotating. Oh, I can just float with the thruster, so I need to adjust the weight of the machine. Okay, not here in the North Pole. Yep, more or less. A little bit to the right. And now I can separate and go away. Yeah, this polar gravity is not working. This thing is not working, and I don't know where is the problem. If it's a problem of my script, or if it's a problem of the rigid body, or how the gravity system, the physics system works in Godot. I really don't know. Anyway, let's fix that, the other level. Where is the other level? Rogue planet. The spaceship is too fast, so let's go 1000. Play, 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 play. Oh, yeah. What? Extremely fast. So this is that level that I need to go 10 times around the planet. If the orbits are not very stable, it will be difficult to get to a lower orbit, do whatever we need to do in the lower orbit, and then return back, because the level will be something like, yeah, leave a probe next to the planet and then go home or something like that. Elliptical orbit. See, but now I'm higher. That's not possible. Slingshot is possible, but how do I gain energy? By falling. And then if I gain energy by falling, I will waste that extra energy by going up again. So If this was true, planet Earth would already be ejected from the solar system from millions of years ago. We didn't. That's not possible. Not possible. Okay. Every time I pass next to it, I gain speed. That's not possible. So something is different. I copied the entire script, so what is different is the rigid body, how the thing works. Internally. And I have access to the rigid body. I can change it, but I don't want to change it because yeah, I update Godot next time and I need to change it again, and or I make my own rigid body, my own. Well, technically it's what I'm doing. The pulls equal to in every distance. Yes, they are every frame pushing into each other. That's why when I start to get closer, I gain speed because I'm closer, and the force of the pulling depends on the distance. So if I'm closer, it will pull more. It's like in real life, in real space, in real. Yeah, I didn't understand what you were trying to ask. If you are closer to the body, the pull force is greater. That's how space-time bends in the universe. That's the rules we live on. But maybe I'm calculating that wrong. Now I'm thinking maybe I can change something that will affect the gravity, polar gravity, but will not affect the drag. Here I have a direction that I multiply by the mass of one thing and the other, and then I divide by the power of the distance. Maybe if I go a little bit more than power or a little bit less, power is power, but you know, instead of distance times distance, maybe distance times 1.01. Let's see what happens if that power is not the number 2. If it's not a poop. Where is the level? Is this one? Yeah. F6. What? But I believe that's you gain speed. I don't know. I don't understand your question. But I believe that's you gain speed. Yes, when you get closer you gain speed, but that's why you gain speed. Yes, because I'm getting closer, I gain speed. That's how real physics work. But when I start to get far away, the attraction is still happening, so I lose speed. It's like when you start to fall. It's like imagine a ball. You are sending a ping pong ball to the ground, and the ground is actually super flat, super hard, so it will bounce as much as it can. If you let go the ball, it will never bounce as high as you let go. It's it's every time it's a little bit less because of drag. But technically, if all the energy is bounced back and in a perfect environment, it should, and if there's no gravity and if there's no drag, it should bounce. Or if there's no drag, it should, if the energy of the bouncing was perfectly 100%, it should reach the same point. But it doesn't because of drag and because of gravity that is attracting. But when you let go the ball, it never goes higher, so it doesn't gain speed when it returns from the planet. Even if you didn't have air drag, and if the surface was a perfect hard surface, and if the ball, all the energy that doesn't transform in it, you know, because that's how the energy is absorbed, the ball gets hotter just a tiny bit, we lose energy in that. But even if that didn't happen, we let go here and the ball will jump to the same height, never higher, or else it's infinite energy. Come on, there's no infinite energy. That's the dream of everyone, and it doesn't happen. You always lose something. It's getting higher, so let's go again. Let's change. I will do this differently because distance times distance. This is the power. Let's not remove that one. So this is the power of the distance. Yes. But let's multiply this one by something else. 1.01. Let's gain a little bit, or maybe not gain, maybe lose 0.999. Let's see what happens. Because if I can find the number here to adjust, to counteract the error that is inside somewhere, I don't need to mess up with drag, and this will be actually balanced in every scenario. So let's say if it passes on the same place. No, it's getting higher. Okay, it's getting higher. So now let's be aggressive with that number and see what happens. So 0.8 is 20% less. Very funny, very funny. Okay, it was different already. But I'm still gaining speed. So maybe it's the opposite direction, 1.2 instead of 0.8. This is a very tricky situation because this is not a simulator, but at the same time the physics needs to be as accurate as I can, or else the purpose of the game doesn't make sense. Still the same problem. So maybe I will not be able to fix it here. 1.05. I believe it's this math here is not working properly. Probably the error is really in your math. Yes, it is. It's a mix of things. Is a mix of things. So even, yeah, I'm gaining speed. I am gaining speed. No, the ship has gravity. Every object that has the polar gravity has gravity. Every element attracts each other. The ship is also attracting the planet. If the ship has mass, it has gravity. Of course, the planet is a little bit heavier. And the ship is lighter. These numbers doesn't relate to real world, of course. Also, the ship is not as big as the planet, almost. Anyway. But what is annoying is that it was working the other game and it's not working this one. So the engine is different. The game engine is different and I need to account for that somewhere. I believe I can do it here. The way I'm calculating this maybe is the thing that is affecting the most, or the other possibility is this float over here. The delta is a double, so it has a lot of precision, and because I need to transform it into a float to apply to the force, because force is expecting floats, maybe I lose some detail here, and that's why I start to gain speed or lose speed, depending on the math above. Something's different. Let's go crazy. 0.5. I can go on Wikipedia and see the calculation for gravity, but it will have much more calculation that I need. That's what I need, because here I'm in a fake to the environment. I don't actually need to have the entire thing. So that number affects so 0.7 70% of whatever. I don't even know what is this, because this is the power of the distance, but this is no longer the power. This is a crazy whatever. I don't know. 70% of something. No, it's already out of orbit. And here again, every lap, every turn, every orbit is to gain speed. That's now how it works. I don't know. Let's, instead of doing the power, let's do the cube. Distance times distance times distance. It will fly away forever. Oh, this needs to happen like this before the division. Let's see. This will not work, even worse. But I don't know. I don't know. Yep. Even worse. Let's Google. Wikipedia. Polar gravity. Polar gravity. Blah 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 blah. The following formula approximates the Earth gravity variation with altitude. And why not use your friend ChatGPT? Well, because ChatGPT gave me the wrong answer. I already tried. Well, maybe if I show it this new way, maybe it finds some error there. But this one, well, this version over here, it was more or less half his idea, half my idea. Because the thing, ChatGPT gave me just one to another, and I need to have multiple, so I need to get them together. Anyway, let's continue to understand how gravity works. Direction, alterations in gravity. Where are we? No, Portugal. Lisbon, 9.801. We are lighter than Paris. In Paris, we weight more. Oh, in London, we weight a little more. In Manchester, Helsinki, we weight more. Strange. So, I guess this is the thing. Yeah. Oh no, it's acceleration at latitude. Gravity is not a simple thing. And try to mimic real gravity. It's not what I want. I just want something that fakes that. But it actually behaves. If I have zero drag, I should have zero loss in energy or gain in energy. Gain I cannot have, but lost. So it's not very easy. Skylab. This was one of the first. I believe this is Skylab. In Unity, I did something like this. I put random objects moving in random directions and they kind of start to stabilize. It's very interesting with these weird patterns. Maybe this is a problem for tomorrow. Maybe this is a problem for tomorrow. I can try what you said, but I believe it will not work. Let me get a new GPT window here. Oh. New features. Connect apps to access files in ChatGPT like docs and spreadsheets. Oh, I can directly send my docs there. This is very dangerous. Anyway. Yeah, it's exactly what I'm going to do. Ask him where is the show him your thing and ask him what's wrong. Yeah. Can you tell me why my polar gravity is making my space objects gain speed when shooting maybe there is another thing. I know why. Tell me. This is the script I'm using for the polar gravity. Let's copy the thing here. So Control A, copy, new text, new file. I don't want to copy everything because it has a lot of garbage. So let's go paste. I want to delete the comments. So it doesn't have the things that it doesn't need to know that I already did to try and whatever. So this does not exist because it will lost. It will try to solve the comments and I don't want to do it. Okay. Let's copy this. Copy. I believe the problem relies on the planet being fixed. Because if the planet does not absorb the energy of the spaceship, maybe it will send back the energy. Gravitational forces calculation. Gravitational force calculation involves dividing by the distance cubed. Oh, wait, stop thinking. You already stopped. It's not distance cube. I copied the wrong thing. It's distance. It's only power. Where is the power? It's here. Let's do this. Math, power, distance, and this is 2. Okay, this is the original. This is the original math. Let's do it again. Send. Multiple bodies interact with each other through gravity. The issue you are encountering where objects gain speed when slingshotting is often due to how gravitational forces are calculated. No shit. And applied to your physics process. Here's some suggestions and adjustments to your code. Force calculation. Ensure that you apply the gravitational force correctly, considering the delta time. Forces are resetted for each frame. They are resetted for each frame. Modify the physics process method. Make sure to reset the forces and apply it correctly to each target. I'm doing that. Gravitational force equals 0. I have that. Differently, but I have that. Gravitational force is equals a new vector. So it's like having a 0. So until here, nothing new. Apply central impulse. Maybe. But yeah, impulse. Impulse works differently from apply force. So maybe. Allow him your thing and ask him what's wrong. Okay, cause you're okay. Nothing new. Debugging. I don't need to look at the numbers. Maybe I can use the impulse method instead of the apply force method. This is happening inside the rigid body manager, but I guess that's not the best solution, because here I'm also adding the engines. So I only access the force once per frame. So instead of apply force, is suggesting to rigid body 2D dot impulse, apply impulse. Applies a positioned impulse to the body. The impulse is time independent. Applying an impulse every frame would result in a frame rate dependent force. So if the computer can produce 300 frames per second, I will have 300 impulses per second. If it's a toaster, I will apply 12 impulses per second, so it will be slower. No, this is like for explosions and something that happens once only. This is also not the solution, and I already tried these things, so nothing new. Fine-tuning, printing, be sure gravitational force are calculated and applied correctly, and taking care of potential numerical issues. Yeah, I believe I have a numerical issue when I transform the delta into float. Ensure that the forces are scaled properly with the delta time to maintain consistent behavior regardless of the frame rate. Yes. One common issue is ensuring that energy is conserved. When objects gain speed, it's often because the gravitational forces are not perfectly balanced, leading to an accumulation of kinetic energy. I will try to unfix the planet and see what happens. Because I guess that because the planet is fixed, it doesn't absorb some of that kinetic energy. And that's why, maybe that's why. Let's say planet, freeze, no longer. But for example, in the other one, the other game, that Earth, that I'm in the stable, that planet is fixed. So if it works there, maybe that's not the problem. I changed something and now it's to what? Ship. Let's go 1000 again. It's not falling. Let's go 0. Play. Oh, of course not. I changed something, but I didn't correct it. When, yeah, I gave the GPT the version corrected, but not here. Polar gravity. Distance times distance. Okay, so let's go 5000 again. See, the planet is wobbling a little bit. This is actually how the things work. Earth does not orbit the sun. The sun also orbits Earth. But we are still gaining speed. So this is not the problem. And it's actually very difficult to get a circular orbit because of the gaining speed problem. I'm always in an oval orbit, see? I gain speed. It's not very normal. Well, that's a future problem because I'm tired. This 4 hours. Wow, 4 hours. For hours, but I need to solve this. Yeah, I need to solve this. Somehow I need to find where I can add some kind of number or multiplication or division to counteract this. Plus equal. Wait a moment. Wait a second. Gravity force equals direction, not increment direction. Oh, but no. who cares? It's resetted here, so it's always 0. It kind of is the same thing. If I remove this plus equal, it should work the same way. Are you there yet? You went to sleep already? Okay. Still above. Do you have any ideas to solve this math problem? I failed math. Well, we all fail math. Distance squared was what? Let me try this function instead of doing this. Direction dot direction is a vector. Direction is a vector. Direction the distance is the length of that vector. Yeah, it will not work anyway, but let's try. Maybe the math is done a little bit different inside that function and the thing works better. I don't know. Let's see if we pass here again. Godot doesn't have a free library of engines. Yes, it's the one I'm using. The problem of Godot engine, physics engine, is that it only simulates down. Because game engines are made to make platform games or something like that. And polar gravity is a very specific, and I'm doing the game in 2D. Imagine if it was a 3D game. Well, maybe that's the thing, because in the other script, in the Unity, I'm using vector 3s, not vector 2s. And even if I just ignore the z-axis, or it's always 0, because this is being applied in a 2D game that just ignores the z-axis. So, but the thing is, maybe if I have, maybe I have a number in z that is being calculated in the distances and somehow is affecting, but I'm pretty sure this z is always 0. It just needs to be a vector 3 because the position is always a vector 3 in Unity, even if everything is flat on the plane 0. No 3D. I have another game for the 3D engine, but I want to finish this first. Oh, I'm tired. I'm tired of the cat game. No, not the cat game. Anyway, I guess I will end the stream. I'm not going anywhere. Yeah, sad. I need to read about calculating gravity. I will try to understand this. What do you think about understanding the Wikipedia of Newton's laws of motion? This is what happens with the sun and with Earth. But because the sun is much more massive than the Earth, this point is actually inside there, so it wobbles. It doesn't orbit. But yeah, it's not this wobbling that is affecting the acceleration. We are still gaining acceleration, and that's not correct. The drag is not a solution. So I don't know. I need to review the math. Or maybe it's just the way I'm applying. Let me do something here really quick. Let's ignore the engines, polar gravity, force. So now I cannot control the spaceship, but I'm only applying the polar gravity forces, even if I'm not pressing the key, so it should be 0. But if now it passes on the line, maybe something's wrong with the input, but I believe it will be above. Yes, same thing, so that's not the problem. Whoa. This is my keys when I press the keys to move the spaceship. So if I do nothing, this is 0. 0 plus whatever it needs to happen. It's whatever it needs to happen, and whatever it needs to happen is too much somehow. Polar gravity force times 0.99%. This is the most dirty way of solving this problem. Go to sleep. You will have a beautiful dream about free returning trajectories. Maybe yes, maybe no. Maybe yes, maybe no. Probably no. Let's go to 19% of the polar gravity force. Only 19%. Maybe I can adjust that, and Yeah, maybe I'll, because the percentage, it's independent from, yeah, less gravity now. Let's see, but if the error accumulates, I'm just accumulating 90% of the same thing, but yeah, it will be, it should not resolve the problem. No, it will not resolve the problem. It's closer. Let's see if it's the same distance now. Well, it's closer, but it's still higher. Let's go 85, 87. Yes, that's it. I will have a fewer percentage of error, but still out of place a lot. So the error is still there, it's still accumulating. It's just being applied differently. I don't know. I don't know where. Well, I don't know. I know the problem is here. This is the problem. This line here is the problem. Is the way I'm calculating the attraction, the gravity force direction, blah 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 blah. The direction is the direction. The distance is the distance. The problem is how much am I multiplying or dividing this mass. The problem is this line, and the thing is the square of the distance, but maybe it's not the square. Maybe it's not the square. How to calculate gravitational attraction. Yeah, center of two objects square, so it's actually square. Gravitational constant times mass of the first object times mass of the second object divided by, well, this is different from what I have. Gravitational constant, I don't have here the constant, but I don't have here the constant, so maybe I will add here something. But yeah, if I don't have here the constant, is like the constant is 1. Because if I have a constant of 1, I will have the same numbers. And I actually have here this. So I guess I kind of have the constant, the number that never changes and sets the entire thing. So the gravitational constant, existing or not, is the same. Mass of the first object times the mass of the second object divided by the distance between the center of the two bodies. This is what I have. I'm just multiplying by the direction because they are moving, so this is a linear gravitational force, and if they are like this, they need to be redirected to each other. So that's why I need to multiply by the direction, but normalized is just because this is not a number, is two numbers, x and y. That's why I need a direction. Tomorrow, I will solve this problem. Do you? My speech is starting to fail. Tomorrow, you will be working at home again or in the office? No. Okay, we don't go to lunch. Yeah, and this is the math I have, and the math I have is the same math. It's here. So I'm pretty sure the problem resides in the rigid body. It must be. It must be. Gravitational constant times mass times separation squared. Yeah, this is what I have. It was working in Unity, it's not working here. So this add force is the problem. Apply force. Something's wrong here. Applies the position of force to the body. A force is time dependent and meant that to be applied every physics update. Something's wrong here. But in the mass of the rigid body, yeah, inside somehow how the force moves the object, the rigid body is a simulator of physics, and when you apply force, it will kind of simulate how that force will translate into pixel movements. Maybe that's a problem, because Unity didn't work in pixels, and the pixel is a very thick measure compared to infinite divisions in millimeters or meters or whatever, because Unity worked in meters, not in pixels. And maybe that's the problem. It's that tiny difference in detail that makes the thing behave normally or not. On the other hand, I don't believe that's the problem, the pixel, because it would be a little bit less error, not so much, I believe. It accumulates a lot in a really, really short amount of time, so something here. force. Let's search for force. Rigid body implements a full 2D physics. It cannot be controlled directly. Instead, you must apply forces to it, and it calculates how it should behave. And the physics simulation will calculate the resulting movement, rotation, react to collisions, blah blah blah. Okay. Well, the problem is, I believe the problem is here. Is inside the rigid body. Maybe I need to program my own rigid body. I don't know. The body's behavior can be adjusted via the lock, rotation, freeze, and freeze mode by changing various properties. Such as mass, you can control how the physics simulation acts on it. A rigid body will always maintain its shape and size, even when forces are applied to it. It is useful for objects that can be interacted with an environment such as tree, blah 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 blah. Yeah, right. If you need to override the default physics behavior, you can write a custom force integration function. See custom integrator. This is interesting. Note that the 2D transform of or linear velocity of a rigid body very often may lead to some unpredictable behaviors. If you need to directly affect the body, prefer integrated forces, as it allows you to directly access the physics state. Okay. Constant force. Integrated force. I need to read about this because maybe I have here some solution. Add constant force, central force. What's the difference between force and central force? Do I have apply central force and force? Central force applies a directional force without affecting rotation. A force is time dependent without the but the other force also does not, or maybe. Let's try central force. Apply central force. Yeah. So my understanding is the same thing, but no, it's already out of orbit. Out of orbit, so this is not the solution. Apply forces. Applies a position force to the body. A force is a time dependent. Okay. The origin position is the offset from the body's origin in global coordinates. No, it's in the center. I don't need to offset. Go. I also need to do that. Integrate forces. Internal forces integration is disabled. This body. Aside from collision response, the body will only move as determined by the integrate forces function. Integrate forces allow you to read and safely modify the simulation state for the object. Use this instead of node.physics process if you need to directly change the body's position or other position properties. By default, it works in addition to the usual physics behavior. Okay, this is to put the thing there without having to move it there, just because I need the object in a specific place. So this is also not what I want. Let me try another thing. If I don't have rotation, does it still goes out? Out of orbit. No, it's not the rotation also. Yeah, something inside the rigid body is not calculating the thing as I was expecting. Let me check if I don't have any stupid setting somewhere. Where is the physics 2D? So here is the thing. I talk about pixels. Default gravity 980. 980 what? You know, because in physics the gravity is 9.8 meters per second. And maybe this is a simulation of that, so that's assuming that 1000 pixels is 1 meter. And if that's true, 1 pixel is 1 millimeter. So that's the small amount of precision we have is 1 millimeter. Physics 2D sleep threshold linear. Threshold linear velocity under which a 2D physics body will be considering inactive. Inactive is below this number. Maybe let's go 0. It never goes inactive. Sleep threshold angular 0. Time before sleep 5 seconds. Physics engine Oh, I have here another one. Default and Godot physics 2D. Maybe we can change and see what happens, but at this point let me see if those numbers, those sleep numbers, change anything. No, I don't like. It's a little bit choppy. So let's reset this. Boom, boom, boom. Let's try run separate thread. If true, the 2D physics server runs on a separate thread, making better use of the multi-core CPUs. Okay. I guess that doesn't change anything. Not working. I don't know where is the problem. Default gravity vector. Set the default gravity direction. No gravity. No direction, but I also have the rigid body with a 0 influence, gravity scale 0. Oh, maybe it's this problem. Maybe I create a problem. I still have here that weird. Oh, but it doesn't have anything. That physical material I had when the moon lander was exploding. But this is nothing. I can remove it, just clear, nothing. And the planet doesn't have physical material, so save. Let's see if it was the physical material that somehow was affecting the thing. But I believe if everything was 0, I think the physical material is only when interactions happen. So bounciness and those kinds of stuff. This is a very difficult problem. I will use the other engine and see. Changes settings will be applied to the editor after restarting. Save and restart. Why not? So we have the Godot physics engine and we have the default physics engine. The question is, why? No, I can revert. It's just change and I don't need to save as. I'm not changing anything. But it's still above. So it's also not at project settings. Godot physics engine. project settings, physics, common, physics ticks per second, 60. So the physics engine works at 60 frames per second. Max physics steps per frame, 8. Physics jitter fix 0.5. Controls how much physics ticks are synchronized with real time. For 0 or less, the ticks are synchronized. Such values are recommended for network games, where clock synchronization matters. Higher values causes higher deviation of in-game clock, and real-time clock, but allows smoothing out frame rate jitters. The default value of 0.5 should be fine for most. Values above 2 could cause the game to react to drop frames with a noticeable delay. And are not recommended. I guess this is a problem for synchronization. Let's do 120 frames per second and let's allow 32 calculations per frame. Let's see if this improvement in speed solves the accuracy. Oh, it changes a lot how it behaves. This is interesting. This is very interesting. It shouldn't happen. If I calculate a thing more times per second, I should get more detail, not less speed. So maybe the delta is not being applied properly, because delta is technically the time that passes things since the last but maybe delta is related to the frame rate, not to the physics process. But if it's true, why do I have delta in the physics process? Why do I need a delta here? Let's break the physics process. The computer will not like this, but I don't really care. Okay, let's go a little bit faster, or change the spaceship to another location. Come on. 11,000. I don't know. I will think about it tomorrow. Yeah, I'm just messing around. I'm trying to change. When I put this slower, the behavior was different, so it could be related with the timing. But if that's true, that means that if you put this game in your computer, the game will work differently. And I need to solve that problem. Because technically, I shouldn't have a different behavior because I'm in a different computer. Yes, I can have less frame rate or more because a powerful computer, but not different speeds. So if the thing is supposed to take 10 seconds to cross the street, it needs to take 10 seconds to cross the street in any computer. Maybe in one computer it takes 10 seconds to cross the street at 300 frames per second, and in the other computer it takes 10 seconds to cross the street at 12 frames per second. But 10 seconds is 10 seconds. See, 980 is the default gravity. In the 3D engine is 9.8. So the 3D engine works in meters. The 2D engine works in pixels. And this is actually one of the things that annoys me in Godot since the first day. Everything should be meters. If it has a physics engine behind it, it should be meters, and then at the end we translate that to pixels to render the image. Maybe here it works okay. Physics engine. I will check if there is another physics engine. Because if there is another physics engine that I can put here and work better, why not? Let's say physics No results. Smoother thin, smoother physics interpolation. Uh, 60 ticks per second, but monitors may have different refresh rates, blah blah blah. Oh. If I set the frame rate to 60, does it change anything? I don't know, what is that setting? Frames per second, frames. Frame delay, no rendering, global illumination. Second. Limits, no. Rendering, no. FPS. Max FPS, let's go 60. No, I don't need to be sponsored by Godot. I'm actually the one sponsoring them by showing my videos in Godot. Let's go a little bit slower. Yep, doesn't affect anything. The frame rate is a visual thing, not a physics calculation thing. Well, I'm tired, and I believe that I cannot think anymore today. So maybe tomorrow I will read something about it. I will search the forums and Reddit and whatever. See if someone has some kind of similar problem related with accuracy in the physics simulations. And if I find something, I will try to implement those solutions. And that's it. I don't want to rebuild the rigid body. I really don't want to do that. And I don't want to go to the 3D engine to make a 2D game. Because it's not impossible to put all these assets in the 3D environment that uses meters. Maybe I can do it just to test, but it will take some hours to solve that problem. Because I need to rewrite all the scripts to work in the 3D space. It's kind of like 3 days of work just to do a test, and I don't know. I don't know. Maybe I just wait for the next version that has this problem solved. Or maybe this is not a problem for them, and I don't know. This is a very complex thing. If I cannot put this working, these kind of levels cannot exist. And that's the boring part. So, I feel the pain in your face. Yes. Anyway, see you in the future.